So there are two special right triangles that we've considered. One of them we called a half equilateral triangle and one we called a half square. When you take an equilateral triangle and you cut it down down the middle this way, we end up with a triangle that's got 60 degrees, 30 degrees, and it has this particular right angle. And there's a relationship between those three sides that we can find out just by reasoning through the dimensions of that triangle and not using trigonometry. The reasoning goes like this. If, for example, I decided to call every single side of my original equilateral triangle 2 units long, then certainly the hypotenuse of my special right triangle, the 30, 60, 90, would be 2 units long. And the side that's across from the 30-degree angle would be 1 unit long. And the reason being there is because if I'm taking half of the equilateral triangle, I've got the 1 and the 1, so that's the side 2. So I've got a 2 and a 1. And then finally this other side, the longer leg, the one across from the 60-degree angle, if I solve that for the using the Pythagorean theorem, I got the square root of 3. So in general, for any right triangle that is a 30-degree, 60-degree, 90-degree, a half equilateral, it'll always be the case that the ratio of these sides are 2 times x, and then x times the square root of 3. So because any triangle that has that 30, 60, 90 would be similar to any other triangle with a 30, 60, 90, this ratio is always true. So that's the basic setup. Now the question is, how do we use that information to solve for a particular triangle? I think the thing that I notice is that if I know the length of the smallest leg, that's the one that's across from the 30-degree angle, if I want to go from that small leg to the hypotenuse, right, I simply multiply times 2. And if I want to go the other direction from the hypotenuse to the smaller leg, if I want to go this direction, I would divide by 2. If I want to go from my short leg to the long leg, you can see right here that I am multiplying by the square root of 3. And if I want to go the other direction, right, then to undo that I would be dividing by the square root of 3. And in any case, this observation, this information that you see on the screen is enough to figure out the lengths of 2 of the sides when given one of them. So 2 quick examples. If I know, for example, that the length of the longest side is 16, then the length of the shorter side would have to be 16 divided by 2, or 8. And the length of the long leg would have to be simply 8 times the square root of 3. So that's probably one of the most straightforward cases, either given the long length, the hypotenuse, or the short leg, figure out the other pieces. Something that might be a little bit more challenging, let's say that you're told that the length of the long leg is 12. Well, if that's 12, probably the first thing I would want to do is figure out the length of the short leg. And if I want to go from that long leg to the short leg, I need to divide by the square root of 3. So I would be looking at 12 divided by the square root of 3. And that is the length of this short leg, 12 over root 3. But we've talked about rationalizing denominators. This is it's a fraction that has a numerator and a denominator. The denominator is irrational. And if I want to rationalize this, I would simply multiply this fraction by the number 1 in the form of root 3 over root 3. And that would give me a numerator of 12 times the square root of 3. And my denominator would be root 3 times root 3, which is 3. So if I simplify that, I would get 12 divided by 3 is 4 times the square root of 3. So the preferred way to write this number is not 12 divided by root 3, but 4 times the square root of 3. And it is a fun fact that if you compare those two, 12 divided by root 3 with 4 times root 3, you're going to get the exact same number on your decimal value on your calculator. Now to figure out the length of my hypotenuse, I'm just going to take this short leg, 4 root 3, and double it, and that would give me that this would have to be 8 times the square root of 3. So that concludes our talk about the special right triangle, the 30, 60, 90, or the half equilateral triangle.